Hi guys, some of you might remember this one if you've been watching some of my videos. It's a 500 watt power supply, quite a simple one with no PFC. And the problem with this one is when you switched it on, you got a kind of burning smell coming from it. Yeah, and it turned out that this chip here blown. This is the pulse width modulator control that runs the main power supply. As I recall, I think we had a 5-volt standby because that's what was powering this chip. But obviously no main supply, yeah, and this was smouldering away, so I had to order some parts for this, and they've turned up. But they were very cheap. Got a bag of like 10 of them for like €1, a couple of euros, something like that with the postage. So the bits are here, and I thought we could have a look at this and replace this chip and see whether or not that actually gets this thing running, yeah. First of all, I think I'll just check first that we do have 5-volt standby, because the 5-volt standby powers this chip, and if that is giving effectively too much voltage, then we could blow the chip again, yeah. So I don't think I ever quite got down to why this had failed. Okay, so let's power this up and let's see if we get any 5-volt standby out of it. Okay, so as per usual, I've got this connected up via the light bulbs, yeah, set to limit, so it will power through the light bulb. If there's a short, the bulbs will come on. Nothing else any worse than that should happen. I've got the voltmeter stuck into the purple wire, the 5-volt standby. I've just balanced this on a bit of paper. High voltage boards, I don't like putting them directly onto the anti-static mat. I don't believe it's conductive, but I usually just stick like a bit of card or paper underneath just to be double sure, yeah. So anyway, we're good to go with this. Let's just move this wire out of the way, tidy up a little bit. There we go, so we're good to go. So let's power it on and let's see if the 5-volt standby actually comes on, yeah. And yeah, there we go, we've got 5-volt standby. So we know that's good. The main capacitors will be charged now. I'll have to wait a little while for all this to discharge, so I'll give that a few minutes, and then we might as well just get and fit the new chip. We know the power supply to it's okay, and let's see if this thing then powers up, yeah. Okay, so we'll just check to make sure that there's no charge in the main capacitors. They should be discharged by now. Yeah, they are discharged. That's safe. So we'll here's the chip. Oops, the wire fell off. Here's the chip, yeah. Let's just disconnect the power as well. I mean, just switched off on the main isolator, but let's have that unplugged as well. So we'll stick this chip in here, and then I've soldered on this wire that's just fell off somewhere, yeah. And then we'll give it a go. Okay. It should be quite easy to do this, to be honest. So hold the chip in place. I just get two ends first just to make sure it's sitting flat on the board, yeah. And then we can just solder these in. Just take a few moments. A bit more solder would help. I think it's going to be quite a short video, guys. Well, I hope so. I hope this works actually once we've replaced this chip. I mean, we don't know why the original one effectively was getting hot, yeah. As I remember, it had like a crack in it, yeah, like a whole crack in it. Some wires fell off here. Oh, this is just the, can you see it? This white wires fell off, yeah. It's the power coming in here, so we'll just have to solder that back on. So this is here. So get rid of that bit of little bit of wire that's stuck in the hole. Should hopefully be able to just push it through to the other side, yeah. I have to just find some tweezers to pull that out of there. There it is, yeah. Ha, I can't get a grip on it. Get a grip, Richard. Get a grip. Can't get a grip on it. Let's have a bit of braid on this, yeah. Oops, sorry guys. A little bit of braid on this just to clean up the solder. There we go. Now the little bit of wire should just come out quite easily. It's probably very hot. Nope. Would you believe it's still stuck in the damn hole? So, you'd think it'd given it up by now, wouldn't you? Really? Yeah, in there. Sometimes it's like the stupidest little things, you know, that cause the most trouble. Yeah. Get hold of this bit of wire here and pull it out. Sometimes it's the stupidest little things that cause all the trouble. Come on out of there. That's it. That's it. Okay. Let's just sort the end of this wire out and stick it back down the hole. And then, yeah, I think we can try this. I mean, you know, either the light bulb will come on bright because something's wrong, yeah, drawing a lot of power. The light bulb will just go on dim and then go off, and there'll be no output, just standby, or it'll work, or something completely unexpected. Something completely unexpected will happen. Yeah, I think that covers all the bases, don't you reckon? Okay, yeah. I'm not like trying to make this video longer or anything, guys. Honestly, I'm not trying to make it any longer than it needs to be. Okay. Solder on this thing. Go. Stick it back down the hole where it goes. And just fix this in place. I had coronavirus vaccination yesterday, and it made me feel ill. Last night I didn't feel good. I felt like I got like a mild dose of the flu. Yeah. I tell you, if that's what the vaccination does to you, that's kind of like a nobbled version of the virus. Just can't do you much harm. I wouldn't like to get the real thing. That's for sure. Okay. There we go. Yep. Soldered in place. What's the situation in your part of the world? You know, you guys are watching these vaccinations. Have you had one? Have you had more than one? I had my first one. I've got to have another one in September the 7th. Yeah. The missus, the wife, she just had one. This Moderna virus, like, you know, only requires one dose. She got the posh one. Yeah. I've got the AstraZeneca one that just needs 2. They wouldn't give me the other ones. No. You have the other one. You have the AstraZeneca, they said. Okay, there we are. Let's zoom out a little bit and let's get the analyzer on this. Shall I see if it works? Okay, so chips in there, yeah. We've got the light bulbs in still, so nothing's going to go bang with this. Let's have a look to see if this actually comes on. So I've got an old IDE hard drive here, old Patter IDE hard drive. It's just to give it a bit of a load, yeah, to run onto. Power supplies much prefer to have some sort of load. That's the analyzer, 5 volt, sorry, like the 24 way and the 12 volt 4 way plugged in. They're all on here, no bits of stray solder, that's all very good. Okay, all we can really do is switch this on and see what it does. And it does nothing. It does nothing. Comes as a bit of a surprise. I thought this would power up, to be honest. I expected this to power up. Let's have a look. First thing, let's see if we've still got 5 volt standby, yeah. Let's see if we still have a 5 volt standby on this. I thought I'd pause the video there, guys, while I was just connecting out. Never mind. Okay, so we're ready to go. I didn't see the light bulbs flash either. That's the other interesting thing on this. There's only wires fell off, and it doesn't look like it. Okay, let's see what we go. 5 volt standby. Yeah, got 5 volt standby. I did see the light bulbs flash that time. Let's just discharge again, yeah, and then we'll see what happens. We'll try it again with the analyzer. Okay, so I've just connected my analyzer back on again. Let's see what she does now, yeah? See if she wants to start up or not. The light bulb flicked once, so I've got mains going into it and it doesn't start. Doesn't want to start. Okay, so we need to get the datasheet again for this chip and have a look to see why this is not starting up. So we're not out of the woods yet with this one, guys. So I've printed off a datasheet. I couldn't actually find a decent datasheet for this KA7500B. I did a quick Google and found on Badcaps forum, badcaps.net, that this is a pin for pin compatible with TL494, which I kind of suspected because on the circuit board, when you unsolder this chip, it actually says TL494, so they're obviously a compatible chip. So this is the data sheet. We can see basically VCC, this is power, is on pin 12. E1 and E2 are the enable pins, which need to be grounded, and C1 and C2 are basically the outputs. There's actually a little diagram here as well. Let me just zoom in on this a little bit. Okay, so you can see a little bit better now. So basically we have 7 as ground, 12 as VCC. It says here 15 volts. This is a typical test circuit, but the chip actually works on lower and higher voltages than that, up to 40 volts, and I think 5 is about the minimum. So we have these pins 9 and 10, which are marked E1 and E2. These are the enable pins. So in this test circuit, they're just connected to ground. This is what your green wire does, yeah? So the green wire connects those 2 pins to ground. The green wire, you know, goes to the ATX. So that's how your motherboard starts it, yeah? And your outputs are on 8 and 9. And it shows you here that the output voltage is basically effectively out of phase, you know, so when one's turned off, the other one's on, and so on, yeah? So one waveform is effectively kind of upside down to the other. And that's a test circuit. So given that information, we can check if our chip's working. So the first thing we need to do is have a look on pin 12 to see if we've got any power, yeah? We need to look on 9 and 10 to make sure the ground, they should be, because that's what the power supply analyzer is doing, it's grounding those pins. And we need to check on 8 and 11 to see if we've got any outputs. So we'll use this with the multimeter and the oscilloscope, and we'll have a look to see what we've got. So I'll just set this up so you can see the camera, so you can see the meter and the oscilloscope, and we'll do it. Okay, so that's ready to go. I've got the oscilloscope probe set on 1 volt per division on the scope. And we're going to make these measurements with reference to ground on the low voltage, yeah? So I'm going to stick the black meter lead, if you just get it into one of the connectors, yeah? I'll just stick it into one of these, that's the black meter lead, so I've got a 0 volts there, that's fine. Right, let's have a look to see what voltage we've got. I've also, by the way, soldered a bit of wire on here. You can see I've taken the circuit board actually out of the case, yeah, and I've actually just soldered wires on from a little plug so I can put power onto this, yeah. If you noticed earlier, there was 2 other wires coming down to the PCB over here, yeah. These are from the 220 volts and 110 volt switch, and the switch is off when it's set to 220 volts. So I can just disconnect those wires. I don't need to have them on there. It's just the same because the switch is open, yeah. So in actual fact, the wires are not connected together when we set to 220. If you wanted to do this on 110, you'd have to just solder a piece of wire from one pin to the other, yeah, if the switch would be closed normally. Okay, so let's just adjust that focus slightly, then let's measure these voltages. I think that's about as good as I'm going to get it. Okay, so let's get the meter lead positive, and first of all we'll go up onto pin 12, yeah, on the chip. So this is pin 1. We count anti-clockwise. Just move these wires out of the way so you can see. They're going to go out of the way. Yeah, they're going to go out of the way. Okay, so pin 12 on here is your supply, which I'm expecting to be more than 5 volts. Yeah, so let's switch this on and let's see what we actually get. Yeah, 8.6 volts. So we've got a supply to the chip. Pins 9 and 10 should be 0 volts to activate the chip. Yeah, so 9 is 0, 10 is 0. Yeah, 12 is your power. So it's activated, we've got power. So have we got any output? Well, you can't easily tell on a meter. We can go, say, look there, there's 1.7 volts, so there's something happening on 8. 9, 10, 11 is about the same, yeah? I've never tried this before, but let's set the meter to hertz and see if I can actually measure a frequency on there. I don't know whether it'll actually do it. Well, let's have a look. Yeah, it's saying 88, 90 kilohertz, so that without using an oscilloscope is basically telling us we have a frequency, yeah? 9, 10, 11. Okay, 100, yeah, so about 100 kilohertz. So we can say we do have an output from that chip. But just to be certain as well, let's just stick this oscilloscope on there, yeah? Now, we're working on the low voltage side of the circuit, the isolated side. So that means it's okay to attach our oscilloscope to the ground. You cannot attach an oscilloscope to the hot ground on this side. You can't connect the ground to it unless you have an isolation transformer, which I actually do have here, but we'll go into that later, yeah? But don't connect your oscilloscope to this side, the high voltage side, the hot ground, because you're likely to blow something up, yeah? Possibly the oscilloscope and the device. Okay, so I've just connected my oscilloscope ground onto here, yeah? Clipped on there. And let's have a look on the scope and see what we can see. So pins 8. Yeah, and there you can see quite clearly we have, oh, I lost the ground's come off. Put the ground back on. Pin 8. We quite clearly have a drive waveform, 9, 10, 11. Yeah, so the chip's running and it's trying to drive the output, but nothing's happening. So the question is, why? Well, I think there's two possible reasons for that. One is that the drive isn't getting to the main switching transistors, or secondly that there's something wrong on the main switching transistors, either no voltage getting to them from the main capacitors or they're faulty. Yeah. So what we need to do now is just wait for this to discharge, and then we'll have to have a look and we'll see if we can trace where the signal goes from this chip. We know it goes to this middle transformer, yeah? That's your main transformer, the top one. This is your standby, and the one in the middle is driving the output device. So we know it goes to that transformer. We need to have a look to see how, and then see if we can trace the signal further, okay? Just let it discharge. Okay, so the capacitor's discharged, and I've turned the circuit board upside down. We can see, and I'll just prove to you, that we have no voltage now in the main capacitors, yeah? Well, a volt, 1.5 volts. As near as damn it nothing, yeah? I've disconnected the mains, by the way, safety. So let's have a look at this chip. So we know 9 and 11 are the outputs here, yeah? And we know that the middle transformer is the drive for these switching transistors. And looking in between down here, I can see a capacitor and a couple of transistors, yeah? Let me zoom in on it a little bit, you'll be able to see it clearer. There's every likelihood that these transistors and this capacitor are involved with driving this coil from here, yeah? So what we'll do, we'll see if we can find a connection from the chip to the transistors to the coil and see if that is the case, yeah? Let's turn the board over and then we'll have a look. So this is where our two transistors are. One's here, 3 pins, yeah? And the other one is just beside it, 1, 2, 3. And I can see that one end of one and one end of the other here, 2 pins are connected together, yeah? One moment. Yeah, they're here. I just zoomed it down a bit for you. So you have, this is the transformer, yeah? Here. No, sorry. that's the standby supply transformer. It's the middle one, yeah? So this is the transformer here. I'll get to it in the end, the middle one, yeah? And this is your main transformer, this is your standby supply. So from here you can see quite clearly this transformer is connecting to these transistors. So that definitely is connecting where we thought it might do. So from the ends of the transformer goes to the middle pin on this transistor, and it'll read right through because obviously this is effectively reads as a short, the transformer, yeah? And it goes to the middle pin on the other one. yeah. And then from these transistors here, if we go back to our chip, so this is pin 8 here, yeah, so you can see it, yeah. This is pin 8 on the chip. Look, that's 9 and 10 which are connected together, which both have to be grounded for it to work, yeah. So this is pin 8, you can see the track comes down this way anyway. So from pin 8, drive to this one, yeah. And from 11, I'm sure we'll drive to the other transistor, yeah. So, and these transistors, if you look, are actually mounted back to front, effectively, yeah. One's opposite way around to the other. They're probably identical transistors, it's just, you know, switch the way around. So, the centre pin of this transformer, I'm guessing these transistors switch in turn, yeah? And the ground, probably, either end of this, yeah, one end and the other, alternately, so the current's flowing backwards and forwards through here, yeah? And I'm sure that will be switching these transistors in turn, the main switching transistors. So, from the centre pin of the transformer, I'm guessing we'll probably go to a voltage supply, yeah? And you'd think it's probably going to go to 5 volt standby. That's the most likely place for it to go, yeah? 5 volt standby. 5 volt standby is a big diode here, which basically, is it this one? No, it's not this one. It's this pin here. It's this pin here. This is 5 volt standby. This is the diode, yeah? So does the middle of this transformer go there? No, it doesn't. Where does it go? It goes to a wire. Goes here to probably a low value resistor. That. Let's have a look. Goes to there. Yeah, about 100 ohms. Yeah. What's by this transformer? Yeah, it's there. Brown, black, brown. That's a 100 ohm resistor. 100 ohms resistor. So it goes to there. Where's it off to that? One's off up this way from the 100 ohm resistor. Yeah, it goes up here through the 100 ohm resistor up to here. Yeah, can you see where I am? I'm up here, look. And this is another resistor. Yeah. It's hard to see. It's brown, green, red. That's 1.5k. What's it reading? 1.5k. You can't quite see the meter, can you? Yeah, so that's okay. Does that go to this diode? Yeah, it goes to the diode next to it. So let's put it back into diode range. Okay, here we go. So this is the resistor it was going to. Try and keep this into shot for. This is the resistor it's going to. This is a diode. So you can see cathode, anode. You can see like an arrow. So that diode reads okay. So does this one there go to 5 volt standby? No. Oh yes, it goes to 5 volt standby via another diode somewhere. Let's have a look. Goes here to a wire link. Oh, and the diode. Yeah, you can see the diode symbol here. It goes there, and this diode should probably read okay. And this is one end of the standby transformer. So that's where it gets its power from. Off a winding on standby, that powers this circuit. So that all looks okay. It checks out okay. So I think what we'll do is now we'll have a look at these two transistors. Yeah, we can see the drive comes in. This will be the base of one. This will be the base of the other. Do the transistors check okay? Let's have a quick look. We've checked everything else. So I'm assuming this is the base. Not sure if the PNP or NPN or if the FETs. Nothing there. Yeah, I got a junction there. And there. That looks like an NPN transistor. It looks like a good one, yeah. Then the base of this. Yeah. I know this is base because this is where the drive comes in, so it makes sense that these two are the base. Remember, one's mounted back to front to the other. Base, probably collector going to the either end of the coil, collector, and then the two emitters connected together, which might well go to ground. Let's have a look. Does it go to ground? No, it doesn't go to ground, it goes somewhere. Okay, I won't worry too much about that, but it goes somewhere. Okay, let's have a look first and see what we've got around these transistors. Do we actually have any drive coming into them? Yeah. I'll just, do I need to zoom out? No, I think you can see quite clearly where I am here, yeah, with the two transistors. Okay, let's put some power back on this. So we'll power it back up, we'll switch it on. We'll get the oscilloscope and we'll see what's going on around here, yeah. So I've got my oscilloscope, I connect to ground somewhere. All this is ground here. You can't see, look. There, yeah, that's obviously all ground. And let's go to these transistors. So we'll go to the base of the first one, yeah. Let's just make that window a bit bigger on the scope so you can see it. There we go. We're ready to power it up. Okay, so this is the base of the first transistor just here. Let's see if we've got anything. I'm expecting to see basically here what I saw on the chip, because that's where it's connecting to. Yeah. So that's got drive. Yeah, let's go to the other one. This is here. That's got drive. What's happening on the collectors? That's this end of the coil. Spiky drive, yeah. And this end of the coil. Drive. So that transformer's being driven. It's on the middle pin. Just drive. I'm a bit concerned that middle pin needs to. Oh no, we know where the middle pin goes. It goes to the up through these resistors up here. Yeah, that's where that gets drive from. What's on the emitters of these transistors? Yeah, just a low voltage, so they're connected near to ground. Okay, so we know the transformer's being driven, but nothing's happening on the other side of it. So now we need to let it all discharge again and have a look. I think what we'll do now is we'll remove the output devices, yeah, the switching transistors, and see. I can't connect the scope to this side of the circuit because there's no safety ground. I can actually, there are ways to do it, but let's just for the moment assume we can't. Yeah, let's see if we can find out where the problem is on the other side. Hopefully it wouldn't be too difficult to work out where the problem is. Okay, let it discharge. See you soon. Very soon. So everything looks okay on the low voltage side of this. I mean, we've got drive to the transformer. We can see that quite clearly, yeah. So I think what we'll do is now we'll have a look at the output transistors. Some soldering on this one looks a little bit iffy as well to me. There's 3 transistors down here. I have power disconnected, by the way, safety, yeah. It looks like the first 2 are connecting together, yeah, they are, and they're connecting via this transformer to this. This is your primary of your main switching transformer, which then connects via a large capacitor to the junction of these 2 capacitors. Yes, it goes via this capacitor to the junction of these 2. We might have to draw this circuit out, but first of all, let's have a look to see if these switching transistors are looking okay. Yeah. So we'll unsolder them and let's have a look to see what we've got. The 3rd transistor on there, by the way, will be the one for the 5-volt standby. Okay, so here are the switching transistors. Obviously, something quite grubby. Yeah. What have we got? We have 2 CM2N. We have a CM2N60. That's this one. It's a MOSFET. That's for the power supply to the standby, 5-volt standby. Another 2, as they often are with these sort of power supplies, are bipolar transistors. It's C4242, yeah. So that's actually a 2SC4242, yeah. And that's these 2. So we need to check. We know this one's working anyway because the standby's working. So let's have a look at these 2. Just get the semiconductor tester, or test it however you want, you know, multimeter. But get one of those cheap semiconductor analyzers that I reviewed actually for like €5 or something, well, less than €10. It wasn't very much. Yeah, did you see that review? I'll put a link onto it from this video so you can see it. Let's get some wires on these. Yeah. What do we have? That's a good one. Well, I'm guessing if that one's good, this other one's probably good as well. Yeah. Yeah. Happy with that one. Go on, let's do this MOSFET while we're at it. We know it's working. But just because the analyzer's so much fun, yeah. Just because they're so much fun. Oops. The wire's pinged off. Oh, there you go, and channel MOSFET. Oop, pressed the wrong button. I didn't press the wrong button, there's only 2 buttons, I just pressed it too hard and switched it off, yeah. Okay. Off. Off. Right, you're off now. Okay, so they're good. Is there anything else we can check while we're here? Yeah, there is actually. Couple of things we're worth checking here. Just clean the dust and dirt out of this, yeah. So there are 2 capacitors here, and you'll always find this where you have the transformer driving the base. There'll be 2 little capacitors, yeah, and those capacitors are involved with the base drive circuit, so it's worth taking them out and checking, especially on older power supplies like this one. I mean, capacitors tend to fail, yeah. The other thing I would say is worth checking is this one. This capacitor connects between one end of the main transformer winding here, yeah. This is one end of the main transformer, and it connects from here to the junction of these 2 electrolytic capacitors, yeah, here and here. This does a lot of work. There's a lot of high frequency current flowing backwards and forwards through this, and I've seen these fail. You also find these on motor control circuits, on disco lights, doing similar sort of, well, not quite the same, they're driving the motors, but it has the same sort of hard life, yeah. So these 3 capacitors, I think we should check while we're here. If there's no problem with these, then we need to have a look to see where the problem is on this circuit. But yeah, let's have a look first to see what these capacitors are like. Okay, so here are our capacitors. These 2 are 10 microfarad 50 volts, yeah. This should be the same, yeah. This one's marked 105J, yeah. The J is a tolerance, it's like 5% or something, whatever tolerance J is, I don't really remember. But 105 basically refers to 1 0, yeah, and then 5 zeros, yeah, and this is in picofarads. So 1000 picofarads, that would be 1 nanofarad, yeah, and this one, yeah, if it was like 1 with 3 zeros, that's a nanofarad, and 1000 nanofarads is 1 microfarad, yeah. So that 105J is a 1 microfarad capacitor. If you want to do that the easy way, just go Google 105J capacitor, yeah. I'm sure you'll find the answer. Google knows more than the wife does, you know, it's amazing. Well, mostly. So 250 volts, 1 microfarad. And any of these failing would probably stop this from working. These fail normally, it blows the transistor, but just because the transistor isn't blown doesn't mean they're any good, yeah. 1 microfarad, okay, so that was, is it 1? No, 10 microfarads, okay. So let's have a look at this one first. Let's get the capacitance meter in here, see what this one does. That's reading 10. Close. I can put the SR meter on them. This thing yeah, it's reading about a microfarad. Let's go again on it. Yeah. Those read okay, to be honest. Stick the SR meter on these electrolytics. Although I doubt a high SR would cause a problem with these. Okay, so first one, let's just zero it. Try again. Try again. Yeah. Try again, short the leads together, hit 0. Okay, that's zeroed. Now let's have a look at these things. That is quite high. Not happy with that. Well, let's try another one to be sure. Yeah, let's find some more. But 18 ohms. Try the other one. It's saying that it's good if it's less than a 10 UF capacitor, and it is a 10 UF capacitor. Let's just grab a couple more capacitor value and see what we read on them. Yeah, I don't have any 10 microfarad 50 volts of the right sort of rating. I mean, these are, I've got a few salvage ones in a little bag here. I've got about a dozen of them. These are, you know, the 10 microfarad 50 volt, but they're only 85 centigrade rated, and the ones I've taken out are 105 centigrade rated. But whether that makes any difference in this instance, I'm not really sure. I could go on bad caps for them, because that's where the capacitor experts are. But if you look at this one, I mean, that's reading like, oh, sorry, stop the leads shorting together, yeah. That's reading like 1 ohm ESR, not like whatever those are reading, 10 or more, 15. Let's find another one. Same rating again, 10 or 50 volts, but only 85 centigrade. Yeah. Stick this one in here, see what this one reads. Yeah, again, about an ohm. I think what we can do is, for now, we'll stick these in just to see if it runs, yeah. I've got a light bulb limiter on, so nothing's going to explode. But those other ones definitely read bad, you know. So yeah, we'll do that. Let's just check the capacitance of these ones as well. I'm sure, because the ESR is good, I'm sure the capacitance is good as well. That would normally be the case. 20 range, plus, minus, yeah. Let's see what we get on this one. We should read 10. Or very close to it. Yeah, just over 10. And those are the ones we're reading just under 10. That's another thing with capacitors, if they read a bit under the rated value. And that one does read a bit under. Oh, shut up, that's a different type. Let's find one. Same type as this other one. Right, in slightly different colour. Yeah, I've got a little bag of them here, yeah. What's this one read? So we find two that read just a bit over the rated volt capacitance, yeah. Yeah. An ESR on this one, just to be certain. Low. Okay, I'm going to put these in. I'm going to put these two in and fire it up and see if it works. The other one, the big capacitor, that looked okay to me. Yeah, okay. Let's put it all back together and let's see what it does. Okay, so there we have it. I've put the capacitors in, connected back onto the analyzer again. We've got power back on again. I think we just have to try this. We're connecting to the current limiter, so I don't think anything too disastrous is going to happen here. Yeah. So let's just switch it on now and see what it does. And the answer is it makes absolutely no difference. So this one's obviously been a bit of a troublesome little bitch, isn't it? But you know, this happens. So we need to have another look around this primary side. I'm sure we've got drive getting to this okay. We need to have a look around the primary side. The other thing I was a bit unsure of on the secondary side, the low voltage side, was whether the emitters of these transistors have got a proper path to ground. Yeah, I couldn't really see that, so I'll have a look at that as well. We know one end takes the supply voltage from one of the secondaries on this little standby transformer, yeah, this one, via this diode that you can just see it here. We can certainly check that. I mean, should be a supply voltage coming onto this resistor here, so it basically goes from the standby transformer through a diode, through a wire link, up here to this diode, through a diode, and through this resistors. I'm going to have a look as well just to see what voltage I've got up here, yeah, which is this is supply to these switching transistors, but we know they are switching. And then I'm going to have a look to see what the path is from the emitter end to ground. There should be a fairly low resistance path, and I couldn't really see that before. Let's have a quick look. So on voltage range, black end in the just sticking into 0 volts. One of these will do fine. Black lead, yeah. So I'm interested to see what voltage we have here, which is the diode which is feeding into that supply for those transistors, yeah. 8.6. What's on here? Only 1.8. Mind though, it's driving a coil, yes. I'm not totally surprised that's a bit low. This is the center tap of the transformer. What's on here? 1.5. We know there's driving because it's on the oscilloscope. Yeah. So what I want to have a look at is the emitter end of these transistors. See, that's got 1.3 on as well. I'm a bit surprised by that. It's got 1.4, 1.3, 1.4, 1.7. There's not a lot of base voltage there. I mean, okay, it's a waveform and maybe I'm not seeing it right, but I'd have thought that the emitter end of these two transistors would have a path to ground. Well, say ground, 0 volts on here. Let me have a quick look, see if I can just trace that bit of the circuit and see where that's going to. Okay, so I decided to have a look and figure out if I could how this is working. Yeah, so this is these two little transistors here that drive the transformer, that drives the base of the switching transistors that effectively give you the full power. The main power rails, 12, 3.3, and 5. So I just took my meter and just looped around and followed the tracks, and I came up with this. We saw some of this, and I was just reading around some voltage as well. So we've got an 8.5 volt supply coming from the 5 volt standby transformer. This is a different diode to the one that actually gives 5 volt standby, yeah. As well as the big diode here. This is your 5 volt standby. There's another small diode, yeah, and that's this one effectively. Looks like that probably has its own capacitor as well, but I didn't bother to check. So basically your supply comes through this 1.5 kilo ohm resistor, 1.5k, through an 100 ohm resistor to what I'm pretty sure is the center tap of the transformer, yeah. And this is how your transistors are connected. I took them out and tested them, they're okay, but they looked okay with the meter. I can see the diode junctions. They're NPN, as I thought, STC945, yeah. The base is being driven by the KA7500B. This is where we get the pulses coming in and turning the transistors on. And what I was saying is, I would have thought that from the emitters, which are all connected together, that there would be a fairly low resistance path to ground, and I couldn't see it. What I actually have is 2 diodes going to ground, and also a capacitor going to ground. I've drawn this here, but in actual fact it probably makes more sense if I draw the capacitor here. It's the same thing, just maybe makes a bit more sense, yeah. So that's what we have. I'm trying to get my head around. I'm not overly familiar with this circuit. I'm not a circuit designer, I'm a circuit fixer, yeah. But a few things strike me. First of all, this resistance seems to be quite high because not much current can flow down here. I don't really see the point of having the 1k5 and then a 1, that is such a small value compared to this. I can't see it makes much difference, but nothing goes from this junction to anywhere else. So there's that. These diodes are obviously reverse biased when the transistor is conducting. So basically, when this one conducts, it goes through the coil this way. So current passes through there, through the transistor, through these diodes to ground, yeah. And when this one's switched off and this one's switched on, the current effectively now goes the opposite way. So it goes that way, yeah, through this half of the coil, through the transistor to ground. The effect of having these two diodes here would basically mean that the emitter voltage of this is about 1.2 volt. It can't go any higher. Yeah, when the transistor is conducting, that kind of clamps it to that voltage. Yeah, but you've also got the effect of this capacitor. So as I can see, when this transistor switches on, I'd imagine this capacitor charges up until it reaches 1.2, at which point it can't charge anymore because of these two diodes. Yeah. And the same when this transistor switches on, the same. So when either transistor switches on, it appears to me this would charge up towards 1.2 volts. Yeah? And then it can't go anymore. When the transistor switches off, can this discharge? Well, you've got these two diodes. I can't quite just get my head around how it would discharge. But I'm wondering if this capacitor is kind of like an essential part to the circuit. It could just be just to keep this no ripple on this voltage here. But what I think I'll do is, because we had some trouble with capacitors on the other side, those two little 10 microfarads, I'm going to take this one out and see what it actually reads. I mean, on the basis that capacitors are the most likely thing to fail, yeah, on the old electronics like this. So without having an exact understanding and without getting to really study it more, which I could, I'm going for the easy route. I'm going to take this capacitor out of here, yeah. I'm also going to take the one next to it as well, because I think that is connected here. So let's have a look at these capacitors and see what these ones are actually reading, yeah. See if we can find some sort of problem here. Because for sure there's a problem somewhere with this, yeah. Oh, it's coming loose. Probably need a bit of leaded solder. I'll just give us a moment. I'll just unsolder these, and we'll just test them, eh? Okay, so these are two capacitors. This one is another one of these 47 microfarad. Sorry, 10 microfarad, 50 volts. Yeah, it's another one of those. And considering we had problems with the other one, makes me wonder if there's a problem with this one as well. Yeah. Because these didn't look too clever on the other side of the circuit. See what this one's reading. Wow. That one doesn't seem to read. That one doesn't read anything. I've got the right. No, I haven't. That's a shame. Wrong lead. So we didn't get too many test meters on the bench, yeah. Okay, let's see what this one's actually reading. No, it's reading 10. What's this thing reading? This is the other one I've taken out. So this is a 47 microfarad, 50 volts. Oh, that's bad. Well, it should be reading 47, yeah. I've got what, 20? The leads are very short on this, a little bit hard to get at. Right, that way. 15, 19, 20, yeah. I bet the ESR of this one's through the roof. Now let's get that ESR meter, let's have a look to see what we have here. Okay. What we got? Well, more than 10, so up onto 100 ohm resistance range, yeah. So up onto 100 ohm, that's 1 ohm, 10 ohm, 100 ohm. So what this one's reading. That's like open. Yeah, that's reading like nothing. Well, that's certainly a bad capacitor. So that's the what's it now? 47 microfarad, 50 volts. That one, I'm sure it connects here. Yeah, and I wonder if this voltage here is lower than it should be, because all this read read low to me. I wasn't happy with them. Okay, let's get these two capacitors. I might as well replace this one as well. And we can read the ESR, but if it's reading high like the other ones were, I think we'll just replace this as well. Yeah, 20 ohms, that's rubbish, yeah. Okay, let's change these two. Okay, so I've replaced these two capacitors. This one was particularly bad. I mean, you know, 22 off rather than 47, and I couldn't even measure the ESR, it was so high. So let's have a look to see if we have any more joiner. Yeah, does this thing actually want to work? Okay, so component analyzer again. Power switched off at the mains, so we can yep, so we can connect the power to this, and once again we'll just switch her on via the light bulb, so nothing can really go too badly wrong here. Can we get the light bulb in shot? No, I can't fit it on, too zoomed in. Okay, well, you can see the analyzer, so you'll soon know if this actually now decides to power up. Yeah, okay, there we go, one analyzer, one power supply. What's it want to do now? Ah, and there you go. It's just saying 12 volts low. That's because I don't have the 4-way here. Yeah. Okay, we'll connect that as well. Yep, 4-way. Okay, so it's now running. Yeah. Voltages are all stable, correct. Yeah, everything's good there. 12 volt, minus 12 volts, always a bit low. Okay, so she's now working. We got to the bottom of that one. I'm not totally convinced these capacitors are the right ones, because the ones I took out were 105 volts, the 10 microfarad 50 volts. I put 85. Not, oh sorry, 105 degree working. I put 85 degrees working in. The little one, the one that was really bad, the 47, that is another 105. The other ones measured okay, but they had, the SR was too high. Okay, sorry if that one was a bit long yet again. Hope you did enjoy it though, and I'll see you very soon on another video. I think I'll do something a bit interesting. I think we'll have a look at this KA7500. I'll put together, in case you don't have like an oscilloscope or a meter with the frequency range on, which I use, I'll build a little tester so we can just plug these things into a little tester and test them. Because I think this, TL494 and 7500B are very, very common. So we'll do that on another video very soon. Anyway, guys, see you soon now. Ciao.